us from around the world. Today we are going to be taking on a very interesting topic, which is the second version of what we have done before in our previous video, and it is, as you can see right here on the board, the effective nuclear charge. Is that right? Now, an effective nuclear charge, as we all know, is the nuclear charge that is fetched by an electron when both the actual nuclear charge, which is Z, and the repulsive effect, which is called the shielding effect of the electrons, are taken into account. And on that very note, we move straight down to the formula for the effective nuclear charge, which is equal to Z minus what now X. And we have said that Z simply means the actual nuclear charge, which is the number of protons in the nucleus of an atom. Is that right? Then we move to what we call X. X, which simply means the shielding effect, also called the non-valence electron or the non-bonding electron. That is it. Now, but we're going to be walking straight down on how can we apply the Slater's rule in the calculation or in calculating for the effective nuclear charge of an electron, of a particular electron in an atom. And that is where the Slater rules come to play. And the steps that will guide us in dealing on Slater's rule are basically, from what I have here, are 3 steps. And the step 1 is you write the electronic configuration for the atom using the following design. Now, this design is based on the Abau's rule. To get me now, Abau's rule, which is 1x, 2s, 2p, 3x, 3p, 3d, 4x, 4p, 4d, 4f, 5x, and 5p, as the case may be. And step 2 is to what now? Is to identify the electron of interest. Is to identify the electron of interest and ignore all electrons in what higher group. For example, you are asked to find the number, to calculate for the effective nuclear charge of a 3D electron, giving you the following electronic configuration. What do we do? Simple. It means our major interest is this 3D. While all other groups, all other atomic orbitals will be what and will be ignored. So my major interest will not be to work on 3D. I can also be asked to find for a 4x. So it means I'm looking for 4x. 4x orbital will be my major interest, while all others will be what now will be ignored. And in another vein, we number them, whereby all the x and the p of the same energy level are grouped together, while the d and the f are grouped together separately. For example, it means from having 1x is on its own, 2s and 2p are grouped together, 3s and 3p are grouped together, 3d is on its own, we group it on alone, 4x and 4p are grouped together, 4d on its own, 4f on its own, but 5x and 5p are grouped together. Is that clear? Now we then move to the number 3 of the rule. And the number 3, which is the Slater's rule, is broken down into 2 cases. And the cases are the case 1 for x and p electrons. Now we have to get, if you ask a question under it, we follow a different approach on it. While for case 2, which involve the d or the f orbital electrons, we follow a different rule in attaching it, which is, we said for case 1 for s and p electron, the first one is A, which is electrons within the same group shield shield this constant, which is 0.35. While for B, electrons within n-1 group shield 0.85. C, electrons within n-2 or lower shield 1.0. Now, you might see this to be cumbersome, but indeed it is very, very simple. Now, for example, I'm asked to find the shielding effect of a 4x electron. Of a 4x electron. Now, as we will know it, since I'm looking for the 4x electron, this 4x you are seeing here is my n. While the next one, which is the n minus 1, this one we shield, meaning this one particular of which is of interest, we always shield 0.35. While the one that is next, which is the n minus 1, we shield 0.85. While the rest of them here we shield was 1.0. That is how easy it is. The same thing also applies. For example, I'm looking for a 3x electron. It means this one now becomes my n, which we shield, which is my interest, which we shield 0.35. The next one follow, which is n minus 1, we shield 0.85. While the other one we shield what now? We shield 1.0. That is how easy it is. That is for the case 1. But for the case 2, which is for the d or the f orbital electron, for example, I'm looking for the effective the shielding constant or the shielding effect of an electron found in the 4f. For example, what do? The rules are for A, electrons within same group, we shield this constant 0.35. While electrons within the lower group shield 1.0. For example, if I'm looking for 4f electron, this one is already my n now. So here we shield 0.35. While the rest of the other group, which are the electrons in it, we shield a constant of 1.0. All right, we'll be solving questions right away. All right, so these are some few examples we solve for you guys. Then I'll teach you how to calculate each of them without making any forms of error. Now, the first question says, what is the effective nuclear charge experienced by a 2p electron in the nitrogen atom? And what do? First step from what we said earlier, that's step 1. First of all, you bring out the elements. This is nitrogen, and the atomic number for nitrogen is what now? Is 7. Now, when we write the configuration for nitrogen, which is electronic configuration, that gives us 1s2, 2s2, 2p3. Now, what do? We group them. Now, the question says, what is the effective nuclear charge experienced by a 2p? Now, what do? You are aware that here is my n, while here is my what now? N minus 1. Then this place is going to be shielding 0.35, while here will be shielding 0.815. Now, because I am looking for a 2p electron, it means there will be one electron that will be removed from this 2p. So if one electron is moved from 2p, I'll be having what class here? I'll be having a 2 electron left in the 2p, which is 2 plus 2 will give me what? 4. So there becomes 4 electron multiplied by this constant 0.35. Right here is 2. So here becomes 2 multiplied by 0.85. So, all right. Awesome. Okay. So here becomes 4 multiplied by 0.35. Then here is 2 times 0.85. Now, which is my x, we're not giving what now? That's 3.10. When you use your calculator to punch it, you'll be having 3.10. Now, but the question says, what is your effective nuclear charge? And you are aware that my ZEFF is equal to Z minus what now? X. Now, my Z, which is the actual number of proton, which is what here? 7. So it's now 7 minus my shielding constant is what now? Is 3.10. So altogether, my final answer becomes what now? 3.95. That's 3.95. That is the final answer. That is the final answer. All right. Which I'm to solve right now. I said, what is the effective nuclear charge experienced by a 3D electron in the bromine what? In the bromine atom. Okay. Now, next example is that of the bromine atom. Now it says, what is the effective nuclear charge experienced by a 3D electron in the bromine atom? So this is bromine, and that the atomic number of bromine is 35. And we write the electronic configuration, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. This is in accordance with the Abba's rule. But you are aware we have said that the way they are arranged in order of their increasing energy level. So I will now rearrange this one to fit into be 1s2, 2s2, 2p6, 3s2, 3p6, 4. Okay, here becomes 3d10, 4s2, 4p5. So what do? I group them. The 1x is grouped on its own, the 2x, 2p is grouped on its own, 3x, 3p is grouped on its own, 3d10 is grouped on its own, 4x and 4p is grouped together, as you can see. Now, but the question says a 3D electron. So if it's a 3D electron, this is my interest. You get me now? So it said 3D electron. Now, it means this is my n, and this n is going to shift 0.35, while the rest, here is n minus 1, here is n minus what now? 2. So it means from, which is here becomes n minus 3, meaning from here downward, we take 1.0 shielding constant. So what do we do now? Now we then calculate for it now. Look at it. Since I'm looking for a 3D electron, so it means there will be 9 electrons left because 1 is being shielded. So there will be 9. What now? There will be 9 electrons that will be shielded from the rest ones. So here becomes 9 multiplied by this constant 0.35. Then we move with the number of electrons here. Here becomes 2 plus 6. Then 2 plus 6. So here gives me what now? 18. So here becomes 18 times 1. So when you add them up, which is the x now, which is 18 times 1 plus 9 times 0.35, should give me 21.15. Because I'm looking for the effective nuclear charge, the effective nuclear charge is equal to Z minus what? X. Z, which is the number of proton in the nucleus, is what now? 35 minus my shielding constant is 21.15, and that gives me my final answer to be what now? 13.85. 13.85. That is my final answer. So we continue in the next example. And in the next example, we're told that find the effective nuclear charge for a 5x electron in structure. In what? In structure. And as such, what do? Now, we write first of all the strontium atom out with its atomic number of 38, knowing fully well that the electronic configuration of structure is in, first of all, this order, but we are to rearrange it to suit the arrangement in order of their increasing energy level according to Abba's rule. So we then rearrange it to be in this order, then we then group. The 1x has already been grouped, 2x, 2p grouped, 3s, 3p grouped, while 3d10 is on its own. 4x and 4p grouped. Then 5x and 5p which they are grouped together. Now, we are aware that since we were told to find the effective nuclear charge for a 5x, meaning here is my interest now, here is my n, here is my n minus 1, here is my n minus 2 downward. So it means here we shift a constant of 0.35, here we shift a constant of 0.85, while here downward we shift a constant of 1.0. So what do? We come here. Remember that if I'm looking for a 1 electron, which is 5x electron, it means I'm to remove 1 from this 2. So here becomes, so I'll be having 1 left, which is being shaded. So here becomes 1 multiplied by 0.35, followed by 2 plus 6, which is 8 electrons here. Here is 8 times 0.85. Then here, which is 10, that's 18. That's 18 plus, which is everything here becomes what now? 28. So here becomes 28 times 1.0. All right. So when we have to get for x is not equal to what now? So we have to add all of them, which is 28 times 1.00 plus 8 times 0.85 plus 1 times 0.35. Altogether, my answer will give me what now? 35.15. So that the effective nuclear charge is not equal to Z minus what now? X. My Z is what now? 38, which is the actual atomic number here, minus 35.15. So when I do the subtraction, the answer should give me what now? 2.85. All right. Okay, so the last example we have to do is, it said find the effective nuclear charge for a 3D electrode in iron. So what do? I bring out the element iron, and iron has the atomic number of 26 as the rules follows. For the electronic configuration to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So what will I do? I will rearrange it. I'm going to rearrange it. I will rearrange and I will group them according to the same energy level that they possess. So here becomes 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, then 4s2. I group 1x, 2x, 2p, 3x, 3p, 3d, then 4x. I am looking for a 3d. So if I'm looking for a 3d, it means this other one is not being considered as part of the rules that I gave to you. That if the one in particular have been known, the other ones will be what now? Will be ignored. So I follow suit. Now, since is for a D, and the rule is for a D, the N here we should a constant of 0.35, while all others we should a constant of what now? 1.00. So what will I do? So I'm looking for a 3D electron, so I have to remove 1 electron from this 6. Only 5 will be left. So here becomes 5 multiplied by 0.35. Then here becomes, so that's 8 plus 8 is 16. That will give me 18. So 18 times 1. So my shielding constant will be equal to 18 times 1 plus 5 multiplied by 0.35, which will give me 19 points. 19 point what? 19.75. So I'm getting 19.75. So therefore, my effective nuclear charge is now equal to Z minus what? X. My Z is the atomic number, which is 26, minus 19.75 equal to 6.25. That's the final answer. So we encourage you guys to like my video, subscribe to my channel, And if you have any question, you can as well relate it with me on this number 09081053321. For any of your questions, they will be solved and response will be given to you immediately. God bless you. And remember, humble self and presently the Bazooka Prophet. Love you guys.